I'm excited about it.
All right, so 3 by 2 box, x minus 6 down the side, x cubed minus 6x squared plus 0x minus 10. So there's a missing term in this one, and I'm going to represent it with a placeholder of 0x. Okay, x cubed, x squared, negative 6x squared. Okay, and I have negative 6x squared already, so I'm going to put 0x squared here. You can put just 0 if you want, but I find it easiest to keep the variables the same. Zero times 6 is 0. I have 0. I need 0. This is still going to be 0. So my remainder is negative 10. A little bit of a weird one, but good for us to do. Okay, so what's the final answer though? It's kind of strange. It's x squared, and I don't write either of these two. And then this is the remainder, so minus 10 over x minus 6. So I guess the moral of the story is just keep going, like Dory, except for she's swimming. I get a really strong feeling that number 4 is going to have quad formula in it because yesterday's was so satisfying and had all whole numbers. I just feel like my life can't continue that way. So here we go. Okay, so number 4 is degree 5, which is slightly irritating, but that's okay. The first thing I notice in my problem is that I have x squared in everything. So the first thing I'm going to do is GCF out x squared, x cubed plus 2x squared plus 12x minus 40. And that sort of makes me feel better about the amount of work I have to do because I was able to GCF out the squared. What does this mean for the graph if I have a GCF of x squared? Yes, there's a balance at 0. Okay, and then I'm going to take the 0 that they gave me and make it x minus 2 as a factor over here. Everybody good so far? Okay, 3 by 2 box. Uh-oh. Stevie, can you slide the thingy for me? Sorry, the thingy slid. It doesn't have enough. It's just getting worn out. Okay. X cubed, x squared, negative 2x squared. I have negative 2. I need positive 2. So 4x squared, 4x, negative 8x. I have negative 8x. I need 12x, so this is going to have to be 20, which always makes me nervous, like I'm getting too big of numbers. But then, oh, it works. Okay, so what do I have? I have x squared from my GCF. I have x minus 2 on this side, and x squared plus 4x plus 20. Okay, now I told you guys I just feel like my life can't be as simple as diamond and box working every time. This is giving me quad formula vibes, but because I'm a thorough lady, I'm just gonna up here attempt the box and diamond just to see, because I should check that first. Nope. Okay, I want to pause here real quick and make a note. This is as factored as you can get it. This is factored for. If the box and diamond doesn't work, you're done factoring. If I just said completely factor, this problem would be done right now. You don't have to launch into the quad formula unless it says find the roots, which I'm pretty sure it does say in the text. However, this is factored form. Final answer, factored all the way. Okay, so x equals 0, double. X equals 2. Everybody good with those? Yes. Okay. All right. Now this guy's going to be a problem. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Equals negative 4 plus or minus square root 16 minus 80 over 2. Sixteen minus 80 is negative 64. Hey, that's good news. That means I don't need to do the tree. Do you guys know what I mean by the tree? Like the factor tree to circle cancel. Okay, negative 4 plus or minus 8i over 2. Reduce negative 2 plus or minus 4i. Okay, count the roots. Do we have them all? Do we have 5? Yep. 1, 2, 3, 4, 5. By the way, these are single complex. There's no such thing as a double complex root. That's not a thing. It's not a thing till calculus. I mean, I don't even know what one looks like, and I do this for a living. So if I throw double complex root at you, I'm trying to throw you off on purpose. Because I'm a jerk. Okay. Okay. We are going to work with one resource page today, but not quite yet. If you could find the one that says the sign calculator on it, it's the one right after the one we did yesterday. This guy, and then says 9.1.3 here, sign calculator. Just scooch that off to the side for the moment. Today you're going to be able to test some of your drawing skills. Great. I know you love it. I cheated and used a compass. So just do your best. I'm a cheater. I'm a cheat pants. A lot of people have success with tracing a water bottle bottom. Um, or you could just wing it and it might look like a potato, or it might look like a square with rounded edges, or it might look like Stewie's head or Hey Arnold's head, whoever you like better, they kind of have the same head. I'm a Stewie fan. Most of mine usually end up looking like potatoes, so if I don't, use the company. I'm a cheater cheat pan. Okay, so I'm going to teach you a lot of things, a lot of stuff right here with this problem. I'm going to use all of this available space here and all of this available space here and all of this available space here for number 27. So we only have two problems today, but neither of them are short. So don't get excited by that. I'm very sorry ahead of time. Okay, first of all, I want to remind you that this is the screamer from yesterday. And on the screamer, you guys remember the screamer? And on the screamer, you get on the ride right here, and then you rotate up like this. Does that make sense so far? Anybody? Make sense? Okay. And I have a couple of things that I really need to teach you about the screamer. The first thing is the labeling. When you guys draw the screamer, I want you to put 0 degrees here. I want you to put 180 degrees here. And then I want you to put 360 degrees back at 0. So this spot right here is 0. It's 360. It's actually infinite number of things. It's also negative 360. So circles work a little bit different from your usual math. There's infinite answers for a lot of these because you're just rotating forever. Okay, and when we make a diagram like this, I will label the degrees on the outside of the circle. And when I ask you guys to draw a triangle in a circle, please, please, for all that is holy, make the triangle hit the circle. Don't like give me a little lame triangle inside. It's gotta like actually go to the edge of the circle on the hypotenuse. It's you're in, people are still not gonna do it. I'm gonna say that. People are still not gonna do it, and I don't really know what to do about that. But anyway, okay. So the first thing I need to teach you is what this is. So I want you guys to put Y here. And I want to remind you from yesterday that what we're doing in these problems is we're using the sine to find the height. Okay, so over here, and this is a new one. We did not do 40 degrees yesterday. So if I was in Math 2 class, I would say the sine of 40 degrees equals opposite over hypotenuse, right? Does that make sense? Okay, and then I would multiply by 1 on both sides, which really wouldn't do anything. So, and then what's the sine of 40 degrees? Zero 0.643 equals y. Okay. If you are seeing that, then that's kind of where we left off yesterday. And so if this is 1, then this is 0.643 tall. Everybody good so far? Okay, now I need to teach you what the things I need to teach you today, which are some vocabulary. And the first thing we're going to say is 40 degrees is called the reference angle. Reference angle. And here's the fun bit. There are actually 4 triangles in this picture that have a reference angle of 40 degrees. Okay, so let me say that again. There are 4 triangles in this picture that have a reference angle of 40 degrees. Okay, so we're going to draw them. And I have a very specific way that I draw them, and you can figure out whatever works best for you. But what I do is I'm going to actually take a different color because I want you to see how I'm making this. So I'm going to extend the height of the triangle until I hit the circle. So the first thing I do is extend the height of the triangle till I hit the circle. Then I line up that spot with the origin and go all the way across the circle. Are you guys getting a better feeling for where those 4 triangles are now? And then I come along the hypotenuse and extend that. And then this is the moment of truth to see if this stuff actually lines up. And a lot of times it doesn't because we're humans and that's okay. These are the 4 triangles I was referring to. These 4 triangles all have a reference angle of 40 degrees. Okay, and I will call this the bow tie all chapter. This is what I will lovingly refer to as the bow tie picture, because it really helps to visualize it properly, thinking about it being a bow tie. You guys know what a bow tie like on somebody? Okay, or bow tie pasta, which is also delicious. But okay, so what I'd like you to do is label in all 4 of those triangles reference angle. Okay, we're going to define reference angle over here in this space. A reference angle is always between 0 degrees and 90 degrees. And is between the hypotenuse. Shout out to Mr. Talbot, that's his favorite math word. And the x-axis in the triangle. A reference angle is always between 0 and 90 and is between the hypotenuse. So what I mean by that is hypotenuse and x-axis, hypotenuse and x-axis, hypotenuse and x-axis, hypotenuse and x-axis. And if you hate that because it's a lot of vocab, just say to yourself, oh, it's the middle angles in the bow tie. And if you like, you can label all the 90s. Not required, but you can. Okay, the next thing I need to teach you, my next goal is how to find the degrees of the three other angles that have a reference triangle of 40. Okay, and what I mean by that is what's the degrees here? What's the degrees here? And what's the degrees here? Okay, so if this is 180, and this is hard for some people, don't have like the full spatial awareness yet. By the way, this part of your brain might not completely form until you're like 23 years old. And why do we make you do this in high school? I'm not sure, but it's okay. Some people are really good at this, some aren't. It's totally, you're gonna get it, I promise. It might just take a little while. Okay, so if this is 180 and this is 40 back from that, so let me say that again. This is 180 and this is 40 back from that. This is 140. Okay, good so far? Okay, if this is 180 and this is 40 forward, this is 220. Okay, so I'm at 180. I went 40 back and 40 forward. Everybody good? Okay, now I come around here and this guy is 40 back from 360. Okay, now if you're somebody that likes formulas, anyone in the room a formula person instead of a visual person? Over here, we're gonna write little formulas for those things that I found. Just in case you're still developing the spatial awareness part of your brain, which is totally normal. In quadrant 1, that's your original angle. I'm going to call it theta. In this case, it was 40 degrees. In quadrant 2, I did 180 degrees minus theta. So I went 180 minus 40. In quadrant 3, I did 180 degrees plus theta. So 180 plus 40. And in quadrant 4, I did 360 minus theta. And if you're a person that likes formulas, you might like that better. It's up to you. We've got multiple modalities here. Okay, I have one more thing to teach you for this problem, and that is the concept of coterminal. Okay, what does co mean? What's the prefix co mean? Think back to your Mrs. Fields training where she has her poop emoji pillow and you're thinking about it, and what does co mean? Yeah, with, together. Yep. Okay, so coterminal angles are together. They are angles, angels. I just wrote angels. Angles at the same place on the circle. Angles at the same place on the circle. I already have two coterminal angles labeled on my picture. Do you see how one of the spots has two labels on it? Look at my circle. Can you see the spot that has two angles labeled on it? Yeah. 0 and 360. 0 and 360 are coterminal angles. It means that spot 0, but it's also 360 if you go all the way around. It's also 720. It's also whatever the next one is, and the next one. It's got infinite answers because you just keep going around the circle. Okay, how do you get something coterminal? There's two ways. You can either add 360 or subtract 360. Tell me what the coterminal angle would be right here. 400, right? Because you go 40 and then go 360 around again. So that's 40, but it's also 400. those are coterminal angles, meaning that they go with each other. They're the same exact spot on the circle. And again, for my formula people, you can say your original angle plus 360, that's 36. That's not going to get you all the way around the circle. Wow. Wow. It's like your Uber dropping you off way too early. Okay. 360. Or if you want to go backwards, you could minus 360. What's a negative coterminal angle for this spot? This is a really, really hard question. Negative 320. There are infinite answers for that spot. Do you want to see why I got negative 320? So you start here, negative 90, negative 180, negative 270, negative 320. So positive rotation is this way. The screamer went. Negative rotation is clockwise, which is kind of counterintuitive. Okay. And put yourself a little note that you can rotate forever. You could find infinite coterminal angles. You could be that jerk. No, jerk. There are always kids who like to mess with the teacher on a test or quiz. And when I ask you for a positive coterminal angle on a quiz, you could just add 360. But there's going to be some guy who's going to add like 47 360s, and then they're going to make me like go with my calculator and figure out if it's actually coterminal. We're just going to let you decide who might do that to me. That'd be their form of hilarious, but it's possible. Okay. The next thing I need you guys to do is find that resource page, the one we were talking about that says the sine calculator. We're finally done with number 27. Oi. Okay. And this is kind of silly, but it's called the sine calculator because it works just like your calculator to find the sine of things. What's the sine that we took this morning? We only did one in the calculator. 40. Okay. And that's the only one we're going to do on here. So I'm going to use my ruler. You don't have to, but here's 40. This guy right there. These are going by 10s, not 15s. I know the last one was 15s and then it throws everybody off. Okay. What I want you to do is draw a line up to the height of the curve and make a dot. Okay, and where should that dot be located? How high should it be according to our notes from a minute ago? 0.643. Yeah, okay. So we're going to label that 0.643. And then I want you guys to tell me what are the other three spots on the wave that have a height or distance of 0.643 from the axis. Okay, so what I'm going to do is I'm going to follow this along here. Here's one spot that has a height of 0.643. And I'm going to trace that down here. And what is the degrees in this spot here? 140. And why does that make sense? It was the other spot in quadrant 2 of our circle. Okay, now you see the spoiler. Okay, now what I'm going to do is I'm going to use the fact that I know that this is 0.643, and I'm going to come along here and be like, okay, here's negative 0.643-ish. Right there. And what spot is that? 220. And does 220 make sense from our screamer? Which quadrant was that one in? Quadrant 3. And then follow that over. And that one's 320. And those were the 4 angles that had a reference angle of 40 on the screamer. And I'm going to stop calling the screamer the screamer. His name's actually the unit circle. But I just like the screamer problem so much, I just keep going to it because it's fun. Okay, now can you guys scooch that back to the side? That's actually done. That's all we do on there. But the question for 928 A and B is, what is the height at 40 degrees? We already calculated that. And then what are the other 3 angles? The And then what are the other 3 angles in the other quadrants? Okay, so 40 degrees was in quadrant 1. 140 degrees was in quadrant 2, which we found here. 220 degrees is in quadrant 3. 320 degrees is in quadrant 4. So the point of that bit of the lesson is just to connect your unit circle back to your sine wave. So remember that a sine wave is created by the height of where you're rotated on the unit circle. And so I don't want to get too far away from the wave. We worked a lot on the circle. We're going to go back to the circle now. And there's more drawing. So, you know, I'm going to reveal slowly so you don't get overwhelmed. Let's start with this one. Yeah, I cheated, but it didn't even work. Look, it's like on the bottom, it's more than 3 boxes. That I don't know what happened. The compass I must not have, I must not have been, I don't even know. Apparently I had improper compass user. Okay, so there's an A, B, and a C. We're gonna practice this 3 times. And I just wrote the chapter 9 quiz, the first one. It's the Friday we get back from break. So 2 weeks from today. And the very first problem is this. Graph the angle and find the other 3 angles and state positive and negative coterminal angles. So we're going to pretend we're taking the quiz right now. Are you ready to pretend to take the quiz? But we're going to do it 3 times. Kind of. You're going to do it 3 times. I'm going to do it 3 times, but not at the same time as you. I'm saying stuff that's really good over here. Okay. I walk in, sit down. This is my picture. The directions say sketch the angle. Okay. And so the first thing I do is I go, okay, this is 0. This is 180. I highly suggest you don't label the 90. You can label the 90. There's a reason for it that I don't suggest labeling the 90, but you can. But everyone should know this is 90. And then what I do is I just back up the train a little bit. It doesn't have to be perfect. We're not going out and getting like protractors and making our angles happen. So I went to 90. I backed up the train a little bit. And this is 80. And then also labeled this as 80. Okay, are you good so far? So that would be Point one on the quiz, sketch the angle in standard position, means locate that spot on the unit circle. Okay, step two is going to say find the angles in the other three quadrants that have the same reference angle. Okay, what I mean by that is we're going to draw in the bow tie like we did before. This one's giving me Darth Vader's TIE Fighter vibes. If I have any Star Wars fans out there. And then put little baby 80s in there. Okay, so step one was sketch the angle in standard position. Step two is to find the angles in the other three quadrants that have a reference angle of 80. Okay, so this is mental math. 180, then back up the train 80 is 100. Does that make sense? So I went to 180, back up the train 80, that's 100. Okay, go to 180. Forward 80 is what? 260. Go to 360, back up the train 80, 280. And that would be point two. I mean, like the second point. So first point, sketch the angle. Second point, find the other three. Third point is find an angle, positive and negative angle coterminal to your original one. Okay, so 80 plus 360 is 440. 80 minus 360 80 minus 360. Negative 280, yep. And there's my full credit response. Okay, I'm gonna put up the next one. I want you guys to practice it. Do it in your groups, please. Try it on your own. We have one more after this, so we're gonna do that one together because it's spicy. And I'm gonna do it up here, but don't look unless you need to. Just look at your own, unless you need to. You can definitely speak to each other. That's fine. Completely allowed. Check your answer when you're ready, and then write down the last one. And this one's 5 feet on purpose. You happen to come across him when you told him I said hi. I had this like great memory of him when we were doing the goal setting thing in Access yesterday. He was like looking at his Aries. It was last year at this time, and he was like, "Oh my gosh, why do I have so many targets to first period?" He's like, "I know one person needs this many targets to first period." He's like, "I'm not gonna have one more target to first period the whole rest of the year." And then at the end of the year, I was like, "Did you get it?" And he's like, "No, but I did so much." It's just like teasing himself. It was great. Okay, last problem of the day, except I want to show you how to start the homework before we stop doing stuff. So negative 750. I'm going to label my stuff still the same. So I usually start with just throwing that on there. And a negative rotation, it's our first time like really looking at it without the coterminal formula, is just going in this direction. Okay, so negative 750. Negative 750 is more than 2 times around. Okay, so let's count. We start at the start. Negative 360, right? Watch my marker. So start negative 360, negative 720, and then 30 more. Let me do that again. Negative 360, negative 720, and 30 more. Okay, so that means that my arrow is going to go here-ish, like 30 degrees this way. This is negative 750. And it's a lot of things, infinite number of things, but that's where negative 750 lives. And right here is the most important part for us. That's 30. Okay, now we're going to sketch in the rest. So I added 360s. So I went 360 because it's 750, right? 360. And then 2 times around is 720. And then 720 to 750 is 30 more. So what I would do is I would go, if I was doing this problem like without demonstrating, I would go negative 750 plus 360. That gets me 1 spin around. Plus 360 gets me another spin around, and then 30 left over. And it would be negative 30 because it's in that direction, not this direction. So I just add 360s or minus 360s till I get within the zone that I can graph. Okay, so where was I? Ruler. Okay, 30, 30, 30. Once you get to 30, pretty much unlock the whole problem. Okay, so this is 30. 180 back up 30 is 150. 180 add 30 is 210. 360 back up 30 is 330. And remember, that's got infinite answers to it. I like to put the between 0 and 360 answers, though. And I have negative 750 plus 360 is negative 390. So it's also negative 390. Negative 750 minus 360 negative 1,110. And it's also negative 30. It's got a lot of names. That spot is infinite answers. Every spot is infinite answers, basically plus or minus 360 of each other. Okay, now find the homework. It's the page after the sign calculator. I'm going to help you do the first few. Hopefully you can finish it today in some other class where you're doing nothing. Only saying that because I hear that a lot from children. Okay. Start here. And so this is the maze at the top, and then the place we're going to put our work is down here in these little boxes. And it says, number 1, find the reference angle of 170. Okay. So I'm going to come down here. These are all sketch problems, kind of. You can use formulas if you want. And I go 0, 180, 170. Does my picture make sense? Okay, so what's the reference angle? 10. Beautiful. To remember, the definition of a reference angle is in between the hypotenuse and the x-axis. I don't even draw the circle on these because it just gets too messy and gross. I just draw the arrow and find the angle between. Okay, so The answer's 10, so you like shade this and go this way. You will not be doing all the problems on here. It's just, you only have to do the ones that is like on that are like on the maze. Okay, find the positive coterminal angle of 72. Okay, there's two ways to do this. You can do it with a picture, you can do it with the formula, you can just do it by knowing that they're always 360 from each other. 72 is about right here. So positive coterminal would be 72 and spin all the way around. You guys with me? So that would be 432. Oh, that's good. That's one of the options. And the reason I label multiple things is because it really helps my brain connect with what coterminal means. It means that that has that many labels in that spot. Are you guys picking up what I'm laying down here? Okay, so you guys can keep going. As long as you just make sure you understand, you don't have to do every problem on this. You just do the ones that lead you along the maze. Actually, I think that next one you could do in your head.